Hello and welcome to another video. In this one, we're going to be talking about hashability in Python, what that means, and how you'll end up using it or implementing it in your own class. And yeah, let's jump into it. Okay, so the idea of hashability comes into play when you're dealing with dictionaries or sets in Python. And all of the information that I'm going to go over in this video, you can get it out of the documentation for Python. So if you look at either hashable in the Python glossary, or if you look at the object.double_hash in the data model documentation, there's a lot to read here. I'm going to go over the long and the short of it. So we're not going to go over everything here, but read these if you want to figure out more about this. But yeah, that's and the way I got there was I googled Python 3 hashability. I got to this Stack Overflow answer. I clicked on the glossary. I changed the 2 to a 3 because we're not dealing with Python 2. I searched for hashable, found this here, and then I clicked on double_hash to get to the other one. So if you want to find those pages, that's how I searched them. But anyway, let's talk about hashability. So the idea behind something that is hashable means that it can be put into a dictionary as a key, or it can be placed into a set. And let me just show you some examples of that. If we open up Python interpreter, if you make any class, by default, it is hashable, but it might not be hashable in the way that you expect. So if we make a dictionary that has a C as a key, you'll see that we have a C object in here. However, that doesn't mean that we can access that C that we put in there by using another C key. You'll see here that we get a key error, and this is because the two C objects that I made, so this C object here and this C object here, have a different hash. And so, behind the scenes, dictionary is implemented as a hash map, and so you need to have a hash in order to go into it. The same is true if we were to make a set of, two different C objects. You'll see that even though they are hashable and they can be placed into a set, they are, not the same hash, and so you get a different value. A lot of built-in objects in Python implement hash already, so things like strings, integers, floats, tuples if they contain other hashable things. And all of those things have this in common. They're all immutable. And what that means is over the life cycle of that object, it doesn't get changed. So if you have a 1, you have a 1, this 1 can never become something else. So x can be reassigned to something else, but this one value, cannot be changed. And how this is actually implemented is there's a pointer to a PyObject structure in memory, and that PyObject structure always has a 1 in it. Maybe a better example is with a tuple. So this tuple cannot be changed. If I tried to assign to it, you get an error because it's immutable. It doesn't allow changing. And so Python has implemented double_hash and double_eq, which we'll get into in a second, and that qualifies it to be hashable. So note that you need to have both a hash function, which returns some integer, and you need to have an equality check. And it will use both of these to place them in a set or dictionary. The reason it has both is the hash space, the key space that you could write a hash function for, is limited to the size of the integer on your platform. So sometimes you will get what's called a hash collision, where multiple objects hash to the same thing. I believe there's some examples. Yeah, so here's like one example where you have a hash collision, and you can use the hash built-in function to check hashes. So the hash of -1 and the hash of -2 happen to be the same value, and the reason for this is Python's internal code denotes -1 as a hash failure, and so that's a reserved value and such as, and so that -1 is special case there. But yeah, if you were to define your own hash function, well, first let's talk about what you get by default. So if we make a class, which we already made above, this has a hash function. You'll see that if we call it, actually we need to initiate C and call it, you'll see that we get a value out of that hash. And it also defines eq, eq, and we make another C here. And in this case, it returns not implemented, which is the default value for the return there. I guess not implemented defaults to false, if I recall correctly. I don't know, the equality chaining rules is a little bit complicated in Python. It mostly works out the way that you expect, but sometimes seeing not implemented is a little weird there. But the way default hashing is implemented is if we call ID on an object, so let's say C equals C. If we call ID on C, this is, in CPython, it's the memory address of this object. Technically, it could be, any sort of other thing, but if we look at c.hash, you'll see that we get a different value. Wait, what? Wait, now I'm confused. I could have sworn hash was based. Maybe it's salted on the memory address. I don't know. That's interesting. What is this value here? Yeah, that's the ID. Huh. Oh, maybe this talks about this. Hash. Oh, it would be in, yeah, here. Object.hash. Let's see. User-defined classes have this by default. Without them, all objects compare unequal, and X returns an appropriate value such that this implies... Oh, okay, I see. So it's not necessarily ID, but it could be based on ID. And the equality is based on ID. So it's only, only C equals C. Any other instance of C will not be equal. And that's the same for, identity comparison with is. So only C is equal to C, and that's the default state of hashable. I actually think this is a negative design choice in Python. I don't think that objects should be default hashable because immutability is actually kind of rare in Python. I find that a lot of ways that people design classes are, you modify them after creation. But fret not, we can disable immutability, and that's really easy. We can disable hashability. The way you can disable hashability is actually a couple different ways. The most explicit way is to just set double under hash to none. This will cause these objects to not be hashable. This also disables the equality check as well, I believe. Oh wait, no, you'll have a default equality check. That's right. The other way that you can disable hashability is by defining your own equality check and not defining a hashable check. So this will turn it off. So if we make another class here, we define, let's actually make an initialization here. Init self x, self.x equals x, and we will define eq, which is an equality check. Return is instance other type self and other.x equals self.x. So if we make one of these objects and we, I should have done a repr. Dang it. E.repr equals lambda self. Let's see. I think I can add a repr after the fact. Name self.x. There we go. So if we make y to e2, you'll see that x does not equal y. If we make another one that's e2, y equals z should be true. Okay, so we have defined equality here. However, we have, by defining eq, we undefine hash, which makes it so that we can't put these objects into a set. Because they are unhashable. So by defining equality, you unset hashability. Now this actually changed in Python 3, so in Python 2 this rule does not apply, and this was to make things a little bit more sane in hashability, although I actually think this is kind of a weirder special case and makes it harder to explain what's going on here. I think it would have been easier to just remove default hashability entirely unless you opt into it. That way there isn't this like, it's hashable by default, but it's kind of this weird hashability, and then you turn it off by defining equality, and then you turn it back on by defining double under hash. But let's talk about, probably the easiest way to implement hash, and that is to hash some value that is immutable inside your container object. So if we make another class here, class f, and oops, and we initialize this with some value here, and again we assign that to here. I'm going to define double under hash, and I will be returning an integer here. Now the easiest way to define hash is to just call hash on a tuple of your values. So it's like self.x. If we had other values, we would pass this in as well. But this will make our own hash for us. You could manually define your own hash by computing some value that should be constant for any value that goes into this function. But I usually find that calling hash yourself is the easiest way to do this. And then the other thing that we have to do for hashability is to define eq. Other turn. We can actually use hash here, but I'm gonna actually use the same equality check that I did up here. And to save us the trouble later, we're gonna implement repr as well. Repr is not needed for hashability, but it is useful to view these objects. So if we have f1 and then f2, you'll see that hash of f1 should always be equal to hash of f1. So that means that these things are consistently hashable. And if we make a set of these, f1, f2, f3, and f1, we should only get 3 of these objects back. Cool. So everything worked out there nicely. So that is hashability. One other thing that I wanted to mention is for the unsetting up here, when I set double under hash to none, if you were to define a function for double under hash that just raises type error, that's actually insufficient for turning off hashability, because there is this hashable abstract base class, and the way this works is it looks for a hash attribute that is a function. So if it's set to none, it will say no, but if it isn't set to none, then it will, it will assume that it's hashable. So if we do is subclass f hashable, you'll see that it is. If we were to look at E was the one where we defined equality but not hash up here, so that is not hashable. And again, if we look at D, that was the one where we set double under hash to none, we get false. And if we look at C, that was the one where we didn't set anything at all, we get hashable. But if we make this bad object here in class f hash self raise, actually should have done G, because we already did f. Oops, not self, what am I doing? Hash self raise type error not hashable. If we do is subclass G hashable, we'll actually get true here, even though this always raises a type error. And this is because the abstract base classes they can't solve the halting problem to know that your implementation is always going to raise a type error. But anyway, that was kind of a lot, but this is hashability, and yeah, hopefully this was useful. If you have additional things you want me to explain, leave a comment below, or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.